Okay, so this video is about the distance and midpoint formulas. Alright, so first of all, you already know one type of distance formula. You know the distance formula is distance equals rate times time. D equals RT. This is a distance formula, but this distance deals with speed and travel distance. It's a different formula. So in this case, we're talking about application of some kind of speed over some space in miles or whatever, or feet. Anyways, that's a different distance formula. This distance formula is dealing with the distance in a coordinate plane. So this is the formula. It's basically the square root of x of 2 subtract x of 1, quantity squared, plus y sub 2 subtract y sub 1, quantity squared. Now, if you get those two quantities added together, you square root that. All right, so that's derived from the Pythagorean theorem. We're going to talk about how it's derived from the Pythagorean theorem in just a minute. Second formula we're going to talk about is the midpoint formula, and this is it. x1 plus x2 over 2, comma, y1 plus y2 over 2. This gives you a coordinate. So it's going to be some coordinate like a ordered pair. This is going to be a length. So wherever we get down with this one, it's going to be some unit of measure like 5 feet or 5 inches or whatever. And this is going to be some coordinate. I will get all this copied down because I'm about to change the screen now. So I'll be sure to pause the video and copy down these two formulas, distance and midpoint formula. I'm about to leave the screen now. All right, so this is the first example. It says find the length of segment JP, given that point J is at the coordinate -1, -3, and point P is at 1, 2. We're going to talk about this two ways. We're going to talk about it visually, and we're going to talk about it using algebra. All right, so first let's think about the visual representation of this graph. So if I actually plotted those points, all right, one coordinate is at -1, -3. So that's a -1, and this is coordinate -3. This is the point for J. And point P is at +1, 2. So it's over at +1, then up 2. So this is the coordinate 1, 2. And the segment JP would be this segment. All right, so that's the segment JP. If you want to find that, if I saw it in a picture like this, my first thought would be to create a triangle with it. If I thought about it this way, made a perpendicular line straight down here, and then met with a perpendicular line straight here, making a right triangle, I can easily see that this is definitely a Pythagorean theorem question. Basically, if I look at the length here, it goes 1 over this direction and 1 over that direction. I know this length is 2 units. And then I look at this length here. It's at 2 on this side and it's 3 beneath. So I know this length is 5. So if I want to find this length of segment JT, I could JP. I could say, well, a squared plus b squared equals c squared, right? So I could say the 2 squared plus 5 squared equals to c squared, because I don't know what this length is. I think it said 2 squared at first, but it's actually c squared. So this is the length I don't know. I'm calling it c. So basically this is 4 plus 25 equals c squared. So 29 equals a c squared, and you get square root 29 and square root c squared, and you get the square root of 29 equals a c. All right, so I know this length has to be the square root of 29. Done. Now let's think about that with distance formula. If I didn't have the picture, I just went straight into the distance formula. Distance formula says d equals the square root of x of 1 plus, well, subtract. All right, x of 2 subtract x of 1 squared plus y sub 2 subtract y sub 1 squared. And if I plug all this stuff in, I first need to go ahead and name these things. Does it matter which one I label x1? No, as long as everything else follows appropriately. Let's call this an x1, and this one y1, and this one x2, and this has to be y2. So if that's true, x2 is 1, x1 is negative 1. So the formula now says 1 subtract negative 1, quantity squared, plus y2 is 2, so 2 subtract negative 3. 2 subtract negative 3, quantity squared. Alright, well that's the square root of 1 subtracting negative is plus, so that's 2 squared, plus 2 subtracting negative 3 means plus, so it makes it 5 squared. And 4 and 25 gives you the square root of 29. So distance formula leads me right to the answer, which is square root of 29. Does it matter to me which one you use? Absolutely not. Either way you choose to do it, it's perfectly fine to me. Fine with me. But that's pretty much how they're related. If you think about this coordinate being x1 and then y1, and this coordinate being x2 and then y2, to find this length here was 2, you essentially got the difference between this x value and this x value. So for this length here is basically, if you're going to find the length, you want to start at the right and subtract backwards. So this length right here was basically x2 subtract x1. We found that was 2. And then you think about the length here. Well, if you look at it, it's basically this bottom length and this top number. So this is basically the y value. So it's basically start on top and subtract down. So this length 5 is basically y2 subtract y1. It's a difference of those two, and that will lead you to the 5. And that's the reason why we could actually come up with the Pythagorean theorem to solve all of this. So basically, if you thought about these two lengths being represented by x2 subtract x1 and y2 subtract y1, Pythagorean theorem says a squared plus b squared equals c squared. And if I solve that for c, I can square root both sides. So I can write the square root of the left, a squared plus b squared equals c. That's what it is if you square root both sides. Now, a is this length here, which we're calling x squared, x of 2 subtract x of 1. So that's the square root of x of 2 subtract x of 1 squared, plus the other one, this is y sub 2 subtract y sub 1. The other length there is here, is y sub 2 subtract y sub 1, so squared, because a was getting squared and b was getting squared. And that's equal to c, or in this case, the distance. So anyway, that's how they relate. That's why this formula is derived from the Pythagorean theorem. You don't have to have to prove that, just know that's where it comes from. I will get down anything you didn't already know as a note, and we'll talk about a new example now. Alright, so the diameter of a circle has endpoints at the coordinates 5, 4, and negative 3, 2. What is the coordinate for the center of the circle? Alright, so they gave you a clue. They said the diameter has endpoints at these coordinates. So I personally would try any kind of geometry question like this without a picture. So I'm going to draw a quick picture of what's happening here. You got some circle, and it has a coordinate at 5, 4. So let's say this is 1, 2, 3, 4, 5. And then up 1, 2, 3, 4. So this is coordinate 5, 4. Other coordinate is negative 3, 2. So over 1, 2, 3, then up 2. Alright, so this and this point connects. And they are endpoints of a diameter, meaning that they lie on the circle. So if I drew a circle that went around there, that's a pretty decent circle. So it don't really look like a real circle, make it look a little better. So I have to go through my words a little bit. Alright, that's a little closer. More of an oval, but you get the idea. It's a circle. But anyway, so basically, if those are my coordinates for my endpoints. I might need to write them too. This is negative 3, 2, and this is 5, 4. If those are the endpoints, I know my center is somewhere around here. I don't really know exactly where it is, but I know it's somewhere around there because it looks like the center. So We can find it exactly though using the midpoint formula. All right, so the midpoint formula says this. So basically, add the x's and divide by 2, add the y's, divide by 2, and that gives you the coordinate. So let's go ahead and name this one x1, y1, x2, y2. So if I add up the x's, I wind up having -3 plus 5, -3 plus 5 divided by 2, comma, add the y's, so 2 plus 4. 2 plus 4, divide that by 2. Alright, so -3 plus 5 is going to give you the coordinate positive 2 over 2 plus 6 over 2. And that reduces to be the coordinate 1, 3. And this coordinate is the center. Center of circle. It's good to go give it a name, what you found. But that's the coordinate for the center of that circle. 1, 3. So I know at 1, 3, the center is actually right there. So it doesn't really look like the center on this picture because nothing's really to scale, but I knew it was in that vicinity right there. Anyway, it's exactly at 1, 3. All right, so that's how I use the midpoint formula. Let's go a step further with both of those formulas. Oh, I will copy down anything needs a note because I'm about to erase the screen. So we'll pause the video and copy down whatever you didn't already know. All right, so last example. It says prove that the figure with the vertices at A, -1, 2, B, 4, 7, C, 8, 0, and D, 5, -5 is or is not, all right, or is not a rectangle. So it could be or it could not be. I wouldn't start any question like this without drawing a picture of it. So you may think it's a waste of time, but you're more likely to get it right. You're way more confident. And plus, if you don't know what to do, just drawing a picture gives you a little time to start thinking about what you should do. So I'm going to draw the picture. Okay, here's my picture of ABCD. I don't have graph paper, so none of this is really to scale, so it doesn't really look like a rectangle. But we're going to assume that it looks better than this. So what must be true about rectangles? You got to know some theories about rectangles. If it is a rectangle, what's one fact you probably know? It has to have 4 right angles. That's one thing that got to be true if it's a rectangle. So if it is, this should be a right angle, this should be a right angle, this should be a right angle, this should be a right angle. So I can go about trying to prove that either they are or they are not right angles. Another thing you need to know about rectangles is this. Opposite sides of parallel. If that's true, it could be any kind of parallelogram. It could be lots of different parallelograms, rhombuses, squares, anything. Well, square is actually a rectangle, so, but it could be a rhombus. So it could be other shapes. So one thing that makes rectangles different from squares and rhombuses is the fact that diagonals are congruent. Now, that doesn't make a difference from squares. I take that back. Squares are rectangles. They're just very special rectangles. They're rectangles with congruent sides. But so all the properties of rectangles also apply to squares. But squares have properties that don't apply to rectangles. But anyway, so diagonals are congruent. So what I need to prove is they got 4 right angles, opposite sides parallel, or diagonals congruent. The best way to get started would definitely be proving that diagonals are congruent or the right angles are happening. Now the question is, how can I prove that these two are right angles? Well, that means these two lines must be meeting at a right angle. So we say these two lines are perpendicular. What do you know about perpendicular lines? Well, you may know they have opposite reciprocal slopes. So that means I need to find the slopes of all these lines. And I need to figure out which ones are opposite reciprocals of each other. So just checking it out. Slope of this line has a rise of So we rose 5 and ran 3. So slope of this line is 5 over 3. I mean, this slope has to be a -3/5 if it's true. So let's look at it. So going down and over. So I went down 7. So I rose -7. I went over 4. So that is definitely not -3/5. This can't be a rectangle because these lines are not perpendicular. So they're not making right angle. So the answer is no. No, it is not a rectangle because it does not have 4 right angles. That's all I have. Good luck.